If you guys read the remind, you guys should know that we're going into lesson 14, which says test review. Obviously, we are not going to be taking a test, so you don't have to worry about that. But the next few lessons for the next couple of days is just going to straight up do review, and that's it. I have not posted the homework, so I'm going to have a homework. It's going to be called a lab. So don't worry about homeworks 13. I guess 13 would be the only homework on there. Don't even worry about homework number 13. You don't have to do that one. I'll be posting a lab on there sometime this evening, but it's not going to be due until next week. Okay? So all I wanted to do is this first page is going to do a little bit of review when you are working with rational functions. And I have all the vocabulary on here of stuff that we have done already. We did this like back in lesson, I think this one was lesson 8 or lesson 9. And then I put one more word problem on here. So I think I'm going to just do this whole worksheet today. Tomorrow we'll probably jump into lesson 15, which is test review day number 2. And then as far as the lab that I'm going to create, it's just going to be similar problems to this. I'm just going to change numbers around. Okay. So with that in mind, again, this is lesson 14, not 13. So if you're confused when you start watching this and you're like, nothing's matching up, that is why. Okay. So I am going to zoom in on this function. We have y equals 6 over x minus 3, all subtracted by 4. So part A is asking us to find the domain of this function. And you guys may recall, we've been doing domain forever. Domain is just the x values. Actually, let me change the style. There we go. So these are the x's. So in order to find the domain, we're actually going to work backwards like we did in the past. Because there's a fraction involved, it's easier to find the x's that don't work first. So you may recall that in order to find the ones that don't work, we're just going to look at the denominator of the fraction. So I'm just going to look at that x minus 3. And the only number that cannot work in the bottom of a fraction is if the answer is equal to 0. Because if it's equal to 0, we said that this means it's going to be undefined. So again, just remember, this is only if we're looking at the denominator and only the denominator. So if you solve it out, this is an easy solve. We can add 3 over to the other side. That is not allowed to happen. X cannot equal 3, because if it is equal to 3, then it would not be a function. It would be undefined. There's no solution there. So to write it out as a domain, we just have to do the squiggly bracket. So this is going to be all of the x values such that, we did that little vertical line, x cannot equal 3. So all x's work except for that 3 value. That's where we're going to have an error. Okay. The next part, I'm going to jump down to part C because domain and range go together. The only difference is range is working with the y's. And when I did this lesson with you guys, when we saw a function that looks similar to what we have now, we can find the y value that doesn't work by looking at the number that comes at the end. So I'm just going to look at that -4. And if we look at that -4, this was called a k value. And they use k for constant, even though constant starts with c. But they use k for constant. And in this case, we just have to say y is equal to that k. And that y being equal to k is not allowed to happen. So if we had y is equal to, in this case, would be -4, that is not allowed to happen when we go to do the range. Because if it did, you would notice on your graph that your graph never would cross at that point. So it's just not possible. It's never going to happen. Okay? So just like we did before, we're just doing it with y's this time. When we go to write out the range, we have all the y values, but y cannot equal -4. Now, that's it. We have our domain, we have our range. So that's the first two vocabulary words that I wanted to go over with you guys. The next part is asking for x-intercept and y-intercept. And it doesn't matter which order we go in because it's just making sure that you guys know how to do it algebraically. I'm not doing anything with the calculator right now because there's no graphs going on here. Y-intercept is just a fancy way of saying x is equal to 0. So all I'm going to do is just take that original function and plug 0 in for x, and I'm just going to solve it out and figure out what that answer is going to be. So if I were to figure out that fraction, 0 minus 3 is just -3, so this is really just 0 over -3 minus 4. 6 divided by -3 would be -2. And -2 minus 4 means that we're going to have a y-intercept at -6. So hopefully that looks familiar to you guys. We didn't do a lot with x-intercept and y-intercept in previous lessons, but that's something you guys have been doing since like 9th grade algebra. So I'm going to jump down to x-intercept now because x-intercept, again, relates just to y-intercept the same kind of way. X-intercept, instead of saying x is equal to 0, it just means y is equal to 0. So I'm just going to plug 0 in for y. And again, I'm going to try to solve this for x. So what I'm going to do is I'm going to make life a little bit easier for us. We don't want to set this equal to 0 unless it's like a quadratic. So I'm going to take that 4 and I'm going to move it to the other side. And now you guys should see you have a number equal to a fraction. And this is something we've been solving for a while. You could just take that 4 and put it over 1. And you can cross multiply. And if you cross multiply, you're going to realize this is going to be just a linear function. And you can solve linear functions for x. So I'm going to cross multiply. And I'm going to say, I'm going to do this 4 times x minus 3. And I'm going to do this 6 times 1. Just make sure when you do 4 times x minus 3, you are distributing it. So it'll be 4x minus 12 is equal to 6 times 1, which is 6. And now the rest of this is just going to be a regular linear function. Get x all by itself. So I can add 12 to the other side. I'm going to have 4x is equal to, that would be 18. And then I could divide both sides by 4. And you can't do 18 divided by 4. So you could leave it as 18 over 4. Or you can reduce it and say that's going to be 9 over 2. Okay. So that's just the x-intercept. That's telling us where it's going to cross the x-axis. Okay, so Notability decided it wanted to crash all by itself. That's great. Did it erase everything I just wrote? Yep. Well, that's annoying. Man, it hasn't done this in a long time. I'm not liking that. So what I'm going to say is if you didn't finish copying that, just go back and watch the video. You can see that it was there until it erased. And then I'll write it back in, and if somebody needs it, I'll send it to you afterwards. So I don't have to waste another few minutes rewriting all that. The only other thing we got to talk about are horizontal and vertical asymptotes. So if you guys don't remember, asymptotes just mean that they don't have a solution. There's no solution when you guys have asymptotes. That's the same thing for down here. Just means that there's no solution. So there's two different types of asymptotes. There's a horizontal going sideways, and then there's the vertical going up and down. A horizontal asymptote will always cross through the y-axis. So this will always be y equals. And a vertical asymptote is always going to be crossing through the x-axis. So it's going to be x equals. Okay? So, that being said, all I have to do is figure out where it was not equal to. We actually already figured that out. We did that in A and we did that in C when we talked about domain and range. We already found the answers where they're not equal to. So domain, where it says x cannot be 3, is actually also known as a vertical asymptote. So this right here is known as your vertical asymptote. So we already know the answer for letter, vertical would be letter F. So our vertical asymptote would be at x equals 3. That's when the answer doesn't have an answer. That's where it doesn't exist. The same thing would happen for horizontal asymptote. We said that's y equals. So if it's no solution, if you look over here at what we did in C, your no solution is your horizontal asymptote. So there's no extra work that we have to do for these because we already did it. So at that one, it's going to be at y is equal to -4. I don't have to put in the not equal to because they're already telling us it's not a solution. That's what we wrote in here. An asymptote means it's no solution. So we already know that y equals -4. That's where the no solution is going to exist. Okay. Again, this part down here, if you want to see it, it was earlier in the video, but Notability crashed on me and erased it. So you're just going to have to go back on YouTube or the Twitch video and check it out. Okay. So that's going over the 6 vocabulary words that we've been doing. Last one's a word problem. I'm not going to spend a lot of time on this one, just like the basic setup of it. So it says that you have a manufacturer can produce MP3 players at a cost of $80 a piece. So for every MP3 player they make, they have to make it for $80. I doubt they have to do that in today's day and age. This question was probably from like 10 years ago, maybe 15 years ago. I bet you they can make an MP3 player today for like probably $10. And then they go sell it in the store for like $50 to $100. But anyways, it's estimated that the MP3 players are sold for X dollars a piece. So we know how much it costs them to make, but we don't know how much it's actually being sold for. Consumers will buy them at 120 minus X a month. So it says express the manufacturer's monthly profit as a function of price. So we did a similar question to this a couple days ago. This is using our profit function because we're looking for profit. So I'm going to write down what that profit formula is. It's going to hopefully look familiar to you guys as profit is equal to the revenue minus the cost. So revenue is how much money the business brings in. It's how much we as consumers buy stuff for. The cost is how much the business is paying to make a product. And the profit is the overall amount of money that the business made. So we just got to break down and figure out what piece represents what. So the cost is actually told in the very first sentence. It says the MP3 players at a cost of $80 a piece. So we actually already know the cost. It's $80 a piece. So we know that it's going to be $80. And we're saying that a piece is represented by our X value because that's the MP3. So it's $80 for every single MP3 player they made. One MP3 player is X, so I'm just going to put X there. So if I made 2 MP3 players, that's $160. If I made 3 MP3 players, it's $240. And we're just going on and on and on. We just don't know what X is. As far as the revenue goes, that's how much the consumers are paying. So this one, and it's written out weirdly, but it's because it's a function. We don't know what X is. It's saying that the consumers will buy 120 minus X of them in a month. So they're buying 120, and I'm putting it in parentheses on purpose. 120 minus X. Now, again, this is representing the number or how much they will pay for it. We also have to multiply it by how many are actually bought. So I also have to put a little X after it. Kind of similar to what we just did with cost. It's $80 a piece, so we had to put X after the 80. Just like revenue, I have to do the same thing because we don't know how many we sold. And then we're subtracting them. We don't know what the profit is. That's what we're trying to find out. So I can just leave it. I'm just going to write it as P, so I don't have to rewrite the whole word. So what they want us to do is just express this as a profit, as a function of price. So now what I'm going to do is I'm just going to solve it out. So I can distribute my X into that first parenthesis, and I'm going to have 120X minus X squared minus 80X. Now I can combine like terms. 120X minus 80X is just going to be represented by 40X minus X squared. And now this function can be factored. We can pull an X out of both of those. So we're just doing GCF. I could pull out the X, and I would be left with 40 minus X. And now we could solve it, and we can figure out what the prices are. So we're trying to figure out how many MP3 players they could sell in order to make a profit. Well, on the left side, if we do the T-chart, that's just X equals 0. Well, if you're selling 0 MP3 players, you're not making profit because you didn't end up selling anything. So we don't even care about that 0. That 0 is gone. That means nothing. On the other side, if you were to solve that, 40 minus X equals 0, I can move the X to the other side, and I'm getting 40. So this is telling us is if we sell 40 MP3 players, that's when we'll start making a profit. So if you were to plug 40 back in the original equation, you guys will see that's when we're going to start making money. This is what businesses do to try and figure out how much they have to sell. Okay? So I'm going to leave it at that. Like I said, I have not added in the homework yet. I'm going to probably add in the lab. I'm hoping before the end of this evening, but I'm not going to make it due until next week anyways. So what I would say is focus on any other homeworks that you guys may not have done yet. If you already got all the homeworks done up until, I guess it would be homework 12. I don't even know if I made a show before it yet. If I didn't, I will do that now. Just focus on those ones. I'll get that lab in there either tonight or tomorrow, and then I'll let you guys know what's going on with it. Okay? See you later, Hannah. See you later, anybody else who's in here. The only other person I see in here is Haley. So, Haley, Hannah, I will catch you guys later. Come to my Zoom or email me if you guys have any questions. See ya.